key aspects of this is creating that digital thread throughout of all of that process. It's about the R&D, the product design, the formulation, how that then goes up to scale up into the production planning and the production engineering, the machines you're going to use, the bottling machines, the filling machines, all that line solution, how it's going to operate. We create a digital thread through all aspects of that. And then you've got your production execution. So this is when somebody hits the green button and you're expecting to produce something off the end of a line. Most companies are talking to us today about vertical startup. How do we design a new product and get it produced in a factory and returning on that investment as quickly as possible? Most companies' return on investment is pretty disappointing. They spend an awful lot on capital, but they don't achieve the returns they're expecting to because of this lag in getting the product from R&D to the consumer, that process. That product execution then, so what we've got is a digital map of where we are. We've got a real map, which is where the data's coming from the real production line. The difference is continuous improvement. Well, the beauty of having the digital thread is now we've got root cause analysis. We've got data we can actually get to the point very, very quickly, which is going to make a difference to actually get that productivity, efficiency, and agility going forward. So, onto the important stuff. So, I'm going to invite Jonathan Hague, Vice President of Unilever R&D for Home Care. And he's going to talk about the product journey or the automation journey, the digitalisation journey of R&D in Unilever around this first phase of this. It's how do we do R&D in a digital environment and scale that up into production. Jonathan.
Okay. If you look at us today, then operating in 190 countries, 2.5 billion consumers. So our consumer reach, you can see the potential of digitization. It's mainly a one-way conversation today in that we're talking to consumers about what our products do. Obviously, as the world digitizes, that becomes a two-way conversation. The opportunity for digital data for Unilever is to make that a two-way conversation and to get primary data from consumers. Because when we can do that, we've got a bigger consumer reach than Facebook. So it's quite an astonishing thought if we could achieve that. And then most of our brands are in leading positions in their markets, around 85%. I think Keith mentioned the D&E footprint exposure. So our growth exposure in emerging markets is bigger than any of our competitors, something like 60% of the business, and it will continue to grow as emerging markets grow faster than the developed markets. It's just a fact. So emerging markets become an absolute priority, and Unilever is much bigger outside of Europe and North America than inside. If I then talk about R&D, so we've just finished installing an end-to-end, across the whole enterprise PLM system, IPLM. It's the data highway through Unilever. So now I can create a product specification in R&D which automatically ships into supply chain, which instructs a machine to operate, and from which we can extract data which provides product information for marketing. So that might sound simple or straightforward or obvious, but retrofitting that into the whole of Unilever's operation with, we have many more SKUs than Ocado to worry about, and of course many more individual raw materials to worry about. It's been a gigantic enterprise, so it's taken us years to establish this and a concerted effort across the whole business. But now we have it, and we're starting to use it. So clearly once you've got the data, you can start to build models, you can start to build simulations, and it's seamless and will feed the marketing machine too. So we're very proud of this, and we're at the beginning. Even after this investment to date, we're still at the beginning of this journey, but it's a fundamentally important journey to get right. I'm going to talk a bit about the Materials Innovation Factory. This is something we've invested in with the University of Liverpool. It's a physical embodiment of our digital ambition. So it's a pretty big investment, 100 million invested overall to date. It started as a concept around 2012. We worked with the university to put together a proposal for the centre. Its ambition is to be the world-leading centre for computer-aided material science. Arguable whether we're there or not, but that's certainly what we set out to do. It's got of the order of about 300 people working in the building today. So that's a completely new endeavour for Unilever and the university. The university use it for automated materials discovery, so the top 2 floors of the building are brimful of PhD and postdoc scientists. Two world-leading academics, both FRSs. The University of Liverpool is the best material science department in the country, arguably, neck and neck with Cambridge, so there's some very high-powered thinkers in there. Unilever's got a floor which is brimming full of automation, so it's in there that we collect data on performance of our products as we develop them. And clearly that feeds the simulation and the modelling and the analytics machine. And then I think quite unique is this open access area, which is also brimming with equipment that has been co-invested in by the university, the government and Unilever, and we've actually transferred quite a bit of our kit from Port Sunlight in there to make it open access, which actually means that we're sharing the burden of quite an expensive block of capital. So that also is open to anybody. So if anybody wants to access the open access area of the University of Liverpool's Materials Innovation Centre, then it's open for business. What did we look at when we were building the Materials Innovation Factory? Well, as I mentioned, the physical embodiment of our digital ambition. So we want to role model how we do R&D. So disruptive digital tools that fundamentally change the way R&D is done. I'll say a bit more about that later. A catalyst, so we actually want it to then proactively change the way things are done. And then in here, we want to hone the skills of the scientists of the future. So a lot of scientists are in our, and technicians generally in our R&D organisation have got very good core skills. So they're good physical chemists, they're good analytical chemists, they're good microbiologists, etc. But they need to now learn to really apply and drive digital skills in doing R&D, because it's not one or the other, it has to be both. So that's the shift we need to make in skills in the organisation. And the Materials Innovation Factory and the people who use it are at the vanguard of that transformation for the whole of our R&D organisation. Just a bit on the open access area. So 4 areas: high throughput formulation, advanced analytical facilities, which is actually invested in by the Royce Institute, which is a materials institute the government set up in Manchester, but as I spoke in Liverpool. Advanced physical characterisation, and then a research hotel. So that's where, I mean, they're all full actually at the moment, but the research hotel is where people can come and occupy the space physically for a period of time. Croda are in there for a period of 2 years, for example, and then use the facilities serviced by the University of Liverpool. But what we've got is a high concentration of kit, which has got the ability to make and measure samples with no user intervention. So that's automated a huge chunk of R&D. In the Unilever 4, then standardise, automate, digitise in formulation is one of the things we do. This is a robot we call Jeff. I won't tell you the story of why he's called Jeff. All of our robots have got a name. There's always a story behind them. It produces 24 800-gram batches of formulation. So if you're dealing with, everybody's gone sort of small scale and micro-titer plate in general in automation. We've done quite a bit of that, but we've actually gone big scale, because actually this is what's important to us. We need enough material to do some proper tests on. So if you want to do a test on a liquid, laundry liquid that you've formulated, you need enough to put it into a mini washing machine to be able to figure out whether it cleans or whether it conditions. So tiny micro-titer plates, not really any good for us. So this capacity of 24 800-gram batches a day is something like 4 times, 5 times what an individual operator could do. But of course, the massive value in this is that it's standardized, so there's no operator error. The robot knows exactly what it's done, exactly how it's formulated. This is the only robot of its type in the world, by the way. And of course, we collect masses of data. And so from that data, and then from the performance data that we collect on those formulations, we can start to build digital models. And so now increasingly, given the data that we've collected, we're using the digital simulations to actually innovate in the marketplace. So, you know, with laundry liquid simulation now, we can create 500,000 formulations in an afternoon, test them in silico, select half a dozen to test in the real world, and then be in the marketplace very quickly. So it's circumvented an awful lot of work. We were going to just show a quick robot of the MIF in action. Is it moving? Yes, it is. This is another one of our robots. This one is called Christina. There are a number of them are named after a famous singer. So Christina is named after Christina Aguilera because she had a song called Dirty. Obvious, isn't it? And what Christina does is actually takes standardized hard surfaces. It could be a plate, it could be a kitchen surface in your bathroom with a standardized soil on it. That can be many things. It could be burnt on oil. All the things you do to abuse your kitchen surface or bathroom surface, we've tried to standardize and put them on plate. And then it takes a cleaning formulation and a standard scrubber and then cleans with a robotic arm, and then takes that rubber, takes the plate and measures the change with a spectrophotometer. And so this is, again, massively less variable than the old way of doing this, which was to try and have an operator be trained to do this in a standard way, right? So you can imagine how much variability there was in data for that. So this has been a fundamental shift for the way we measure our hard surface cleaning, and once again is leading us to much more reliability, much faster route to market, because we've got the confidence to go direct to market from these measurements, and also then the ability to build models. So that's not the end of the day. I mean, if you look at the history of where we've come from, this is a lab in Port Sunlight, the very first lab across the water there. You can see it's probably the most unsafe lab you could imagine today, but it doesn't look a lot different other than the materials of construction than a lab from the sort of 1990s. There's maybe the odd computer in here, and the scales are electric, not with little weights and balances. But there's no fundamental shift between the year 1900 and the year 1990 to 2000 in those laboratories. The step to automation obviously gives us a big step up and a big shift in data, but clearly where we want to get to is fully in silico. So that's the journey we're on, because then you get to be fully predictive, and the number of formulations you can design per day per person goes into the thousands, if not more. So the cleaning products that we use, we need to actually find out their phase behavior. When I started in Unilever, it took 3 months manually to map out a whole phase behavior like that. It's now a 30-minute job on a high-performance computer to do it with mesoscale modeling. So this is now deeply advancing our understanding of what our products do and accelerating our ability to formulate into spaces that we know that will be useful. Obviously, that's not enough. You need to think end-to-end, and I think this is very similar to Keith's chart, which talks about looking across the whole of the life cycle. So you can start with fundamental studies. There's a lot of optimizer engines around. There are now a number of virtual suites for product development that are in. So nearly all of our packaging is now done with virtual technology and 3D printing to prototype. And often we can simulate and don't need to do any physical prototyping to at least get designs agreed. There's quite a lot of work on factory line optimization. So similar to the way we were talking about earlier, I think understanding the process flow through a continuous reactor in our factories can tell us whether a shampoo is in spec or not, and can be released based on flow parameters rather than doing quality control on the lines. So that's a brilliant step forward in efficiency in continuous reactions in our factories. And ultimately, manufacture to demand will come. Scaling up from our robots in the Materials Innovation Factory to a 10,000 litre reactor in Port Sunlight factory over there is still a bit hit and miss. We don't yet have fully predictive ability to do that. And it's complex, and the reason it's complex is because products form microstructures, and those microstructures are extremely sensitive to process conditions, and process conditions don't necessarily scale from small to big. So we've actually invested in a materials innovation, an advanced manufacturing centre also at Port Sunlight. So that was the latest investment there, which really sits between the materials innovation factory and the robotic scales that we've got there, and then the large scale of the factory. So this is now up and running. When you walk in it looks like a factory. It's really of quite significant scale. Covers all of our liquids processing scale up, and also contains a good deal of packaging machinery, because we've not talked about it much today, but there's an enormous challenge to increase the level of post-consumer recycled plastic that we're putting into our products to avoid it to go to waste. So we're doing an awful lot of that work in here. That's now fully sensored up. So we capture all of the data from that scale up into a cloud system. Also metadata, so you can make observations, take videos of what's happening as you're doing your processing. But the point here is to actually get a really good digital handle on the scale up of our processes.
Hi John, great presentation, thanks. What's the holy grail in terms of time from R&D development to full-scale manufacture in your future world?
So can you still hear me? Yeah, okay. So it depends. I think we've, I mean, in systems where we're actually able to use optimizers, then it's almost instantaneous. So you can, based on incoming costs of raw materials, you can change almost batch by batch. So we do that in soap making, we do that, or we used to do it in margarine, but we sold that business. The new molecule to market, our record at the moment is about 1 year, which it's quite spectacular actually. So, you know, taking a thickening polymer, putting it into a laundry liquid, designing the molecule from scratch and commercializing about a year. We're routinely offering a sort of 2 to 3 week turnaround on fast response to competitor challenges. So there's a range of timescales from instantaneous to, now there are still some things we do that are taking more than that time, but that gives you a range of answers.
One final question around collaboration really, and do you see now with you're obviously in R&D, you're seeing greater collaboration across the different parts of the business through operations, and is digital enabling that?
Yeah, definitely. So, you know, I talked a little bit about optimizers in the factories. Quite a lot of that work, the initial analytics was done from R&D, so that's helped with production efficiency, just using tools that R&D had developed. I think as we see the R&D become the custodian of product information, product data, which now needs to fuel brand.com websites, e-com websites, then the interface between R&D's, if you like, data machine and how that translates into product information for the business has really been developed very, very fast. So that's an absolutely critical collaboration. Given in the end, the value of data, or one of the values of data, product data is actually in service of what consumers want, back to this point about transparency and so on. Yeah. So we still run into problems now and again when we get the artwork wrong. We forget to label that there's an allergen, it leads to a recall. I mean, that's R&D data that's caused the problem. Somebody translating it into a pack or a website has made a mistake. Clearly we want the systems to iron out all of that, and collaborating to get those systems to completely intermesh is what we're looking to do now.